The power of neutron stars. What happens when they collide? Imagine the universe's most intense, dense, and mysterious objects, the remnants of giant stars that have died spectacular deaths. These are neutron stars. In their cores, atoms are squeezed so tightly that a teaspoon of their material would weigh billions of tons. They are the dead hearts of stars, compacted into something so small, yet so incredibly powerful. Now imagine two of these cosmic beasts on a collision course, spiraling toward each other in a deathly dance. What happens when they collide? The answer is an explosion of such magnitude that it reshapes space and time itself. The dance of death. When two neutron stars orbit each other, they are locked in a deadly embrace. Their immense gravity pulls them together, gradually stealing their orbital energy. This energy loss doesn't happen peacefully. It causes the stars to spiral inward, inch by inch. Over millions of years, the distance between them shrinks and their speed increases. They spin faster, hurling around each other at mind-bending velocities. During the final moments, their speeds approach a significant fraction of the speed of light. The energy in the system becomes monstrous, and the collision is inevitable. As they spiral in closer, neutron stars begin to distort each other's shapes due to tidal forces. The immense gravity stretches and compresses them, making the stars swell and warp like they're being pulled apart. At this point, they're no longer serene dead stars. They're ticking time bombs on the verge of the most violent explosion you can imagine. The moment of collision. When these two stars finally crash into each other, it's no ordinary explosion. It is one of the most cataclysmic events in the universe, a kilonova. The collision releases an enormous amount of energy, creating a shockwave that ripples through space at the speed of light. The energy emitted is so intense that it creates gravitational waves, ripples in the fabric of space-time itself. These waves are powerful enough to be detected millions of light years away, stretching and squeezing everything in their path, even our very planet. The collision doesn't just release energy in the form of gravitational waves. It also sends out bursts of radiation, including gamma rays, the most energetic type of light. The gamma ray burst from a neutron star collision can outshine entire galaxies for a brief moment, releasing more energy in a few seconds than the sun will produce over its entire lifetime. Out of the chaos comes creation. In the aftermath of the collision, the debris from the neutron stars forms a cloud of material that undergoes a process known as R-process nucleosynthesis. This is where some of the heaviest elements in the universe are formed. Elements like gold, platinum, and uranium, the building blocks of planets and life, are forged in the extreme conditions of the kilonova. The material is ejected into space, where it can eventually become part of future star systems, planets, and even life forms. In a way, neutron star collisions are the universe's way of recycling its most precious materials, scattering them across the cosmos. What remains after the collision? That depends. If the two neutron stars were relatively small, they might merge into a single massive neutron star. But more often than not, the combined mass of the stars exceeds a critical limit, and the result is far more sinister: a black hole. This newborn black hole is a gravitational monster, devouring the debris from the collision and warping space-time around it. Nothing, not even light, can escape its pull. The energy involved in a neutron star collision is almost impossible to comprehend. To put it into perspective, the collision of two neutron stars releases as much energy in a matter of seconds as the sun will release over 10 billion years. The forces at play here, gravity, nuclear fusion, and the bending of space-time, are the fundamental powers that shape the universe itself. But there's more at work than just raw energy. As the stars collide, they emit gravitational waves which distort space-time and provide clues about the inner workings of the universe. These waves travel across the cosmos, carrying information about the neutron star's final moments. Thanks to advanced detectors like LIGO and Virgo, scientists can listen to these waves and learn about the mass, spin, and distance of the stars involved in these cataclysmic events. Gravitational waves also provide insight into one of the universe's greatest mysteries: the nature of matter at its most extreme. Inside neutron stars, matter exists in a state that we cannot replicate on Earth. The collision of neutron stars offers a rare glimpse into the behavior of matter under pressures billions of times greater than anything we can imagine. These collisions could hold the key to understanding the fundamental forces that govern the universe, including the elusive force that binds atomic nuclei together. Though these events take place millions or even billions of light years away, they have a profound connection to us. The heavy elements created in neutron star collisions, like gold and platinum, are present on Earth. Every time you look at a piece of gold jewelry or see platinum in a laboratory, you're holding the remnants of a cosmic catastrophe. These elements were forged in the heart of a neutron star collision, flung across the universe, and eventually became part of the planet we call home. The collision of neutron stars is not just a spectacle of destruction, it is also a process of creation, a cosmic cycle that links us to the farthest reaches of the universe. These collisions remind us that we are part of a universe that is violent, dynamic, and endlessly creative. Neutron stars, in their death throes, give birth to new elements, new worlds, and perhaps new forms of life. When neutron stars collide, the universe is both destroyed and reborn in an instant. The titanic forces unleashed reshape the very fabric of space and time. From the fiery chaos, new elements emerge, spreading through the cosmos to seed future stars, planets, and life. Neutron star collisions are a testament to the power of the universe, a reminder of its destructive potential and its ability to create from the ashes. In the grand, dark dance of cosmic forces, neutron star collisions are both an ending and a beginning. They are one of the rarest and most powerful events in the universe, a phenomenon where the unimaginable becomes reality, and the remnants of dead stars reshape the future of the cosmos.